Good morning students, this is Premchand, a chemistry faculty, Vikas Global Institution, Jangaredgudem. In the last three classes, we were discussing about atomic structure and subatomic particles. We were seeing all points like how did they discover the subatomic particles by experiments and all. Today, we will solve few objective questions. We will take up few questions from our book. So, the first question goes like this. One of the fundamental particles is missing in one of the isotopes of hydrogen atom. The particle and isotope are respectively. We saw fundamental particles. Fundamental particles. What are they? There are many subparticles in an atom, but we saw fundamental particles as electron, proton and neutron. Right. So, he also gave is missing in one of the isotopes of hydrogen. So, we should know what are the isotopes of hydrogen. There are three isotopes of hydrogen. The first one is protium, 1H1, 1H2, 1H3. This is called as protium and this is called as deuterium, and the third goes as tritium. Right. So, we will see more into detail when we come to the isotopes topic, but as of now, the mass number, we should know about the mass number. What is the mass number? Mass number is nothing but number of protons plus number of neutrons. So, number of protons plus number of neutrons, that is what the mass number is. So, this is about the mass number. We call it this as A, mass number. And atomic number. What do you mean by atomic number? Number of protons or number of, we'll write or number of electrons. Because in a neutral atom or neutral species, we have number of protons equal to number of electrons to maintain the neutrality, because they are having positive charge, this is having negative charge. So, whenever I say number of protons, we are taking this number, which is, this is the atomic number and this is the mass number. Right. So, if I take the mass number of hydrogen, I will take this one, 1 plus number of neutrons, I cannot keep anything because the total sum is 0. It has to be 0 for protium. Right. Whereas for deuterium, it is 1 plus 1. For tritium, 1 proton with 2 neutrons. Right. So, we have to take as mass number of hydrogen, like protium is nothing but number of protons is 1 and number of neutrons is 0. It does not have any neutrons. So, the fundamental particle which is missing in the isotopes of hydrogen is, in which of the isotopes one is missing? Yes, this is protium. In protium, the neutron is missing. So, the correct option will be neutron and protium. We will take up the next question, that is, the charge of an electron is 1.6 into 10 to the power minus 19 coulombs. What will be the charge of Na plus ion? Charge of electron, they are giving 1.6 into 10 to the power minus 19 coulombs, and they are asking the charge of Na plus ion. Right. So, Na, what is the atomic number of Na? It is 11 for Na atom. How does it become Na plus? So, Na, when it is losing one electron, it becomes Na plus. Because in a neutral species of Na, there are 11 electrons and 11 protons. This is negatively charged, this is positively charged. If I remove one electron from here, then it is 10 electrons and 11 protons are there. One positive charge is extra. That is why we are getting Na plus. Till 10 electrons plus 10 protons, it is neutral. But when one proton is extra, it is having a charge. So, they are asking that charge. What is the charge of that Na plus ion? Which means they are asking that extra proton charge. What is the charge of a proton? Yes. So it is just opposite to that of electron. 1.6 into 10 to the power minus 19 coulombs. Because for electron we keep it negative because it is negatively charged particle, but whereas for proton we call as plus 1.6 into 10 to the power minus 19 coulombs. In magnitude both are same. So the answer will be, options given are 1.6 into 10 to the power minus 19 coulombs. The option second one is 3.2 into 10 to the power of minus 19 coulombs, 2.4 into 10 to the power minus 19 coulombs, and 10 into 1.6 into 10 to the power minus 19 coulombs. So the correct option will be 1.6 into 10 to the power minus 19 coulombs. Alright, we will take up the next question, that is from the cathode ray properties. You have seen cathode ray properties in the cathode ray tube experiment, right? So in the cathode ray tube experiment, what did we saw? It is independent of gas present inside, it is independent of cathodes or electrodes, whatever we are using, we have seen. So based on that it is given here. So the options are like, which of the following is correct for cathode rays in discharge tube, that is what is given. So first one is independent of nature of cathode. The second one is independent of nature of gas, and the third one is deflection is observed in electric field and magnetic field. These all properties we have seen in the cathode ray tube experiment on the properties of electrons or the cathode rays. The fourth option is all the above. Yes, it is independent of nature of cathode. Yes, it is independent of nature of cathode. Irrespective of whatever we are using the cathode or anode, they absorb the cathode rays, and they also absorb the independent of gas. Whatever the gas we are using, still they are able to see the cathode rays, and it doesn't change the value of charge to mass ratio. At the same time, in the presence of electric field and magnetic field, like J.J. Thomson experiment, we have seen like how did he apply both electric field and magnetic field, and he is able to observe the charge to mass ratio of an electron. So the correct option is all the above. These three are right. So the correct option we have to keep here is not all, but we have to keep all the above. Right. So the next question is also same on the cathode ray properties. The specific charge for a cathode ray, they are asking specific charge. Specific charge is nothing but the charge to mass ratio. Charge to mass ratio of cathode ray, which means they are asking about the electron. So whatever they are giving, we will see the options. The first one is has the smallest value when the discharge tube is filled with gas. Smallest value in H2 gas. The other option is constant. The other option is varies with atomic number of gas in the discharge tube, which means varies with gas. Yeah, you can say atomic number of gas varies with atomic number of cathode. Remember, do you remember that in the cathode ray tube experiment, it is constant irrespective of gas we are using, also irrespective of cathode we are using. Whatever the material you are using, you are able to observe the cathode rays. And yes, again they are asking about a specific gas, if it is smallest or the largest by using the specific gas. So it is constant by using anything like whatever gas we are using or whatever the cathode and electrodes we are using. So the correct option will be it is constant. And we go to the next question. The specific charge for positive rays is much less than the specific charge of cathode rays. This is because they are asking the reason why specific charge of cathode rays, which means that of the electrons, and specific charge of is positive, right? So specific charge of electrons and specific charge of protons, which means charge to mass ratio of protons, specific charge for positive rays is much less than, which means it is less than specific charge of cathode rays. Why? Because they are asking basically this one. Why specific charge, which means charge to mass ratio of proton, is less than charge to mass ratio of an electron? Why? We have seen that in when we saw the experiments while finding out the proton, that there is a mass of proton is much less than mass of electron, right? What is the mass of proton? 1.673 into 10 to the power minus 27 kg, while that of electron is 9.1 into 10 to the power minus 31 kg. If you see this one, this magnitude, it is minus 27 and minus 31, which is higher. This one is higher, right? So mass of proton is higher than mass of electron, which makes charge to mass ratio of proton is lesser than the charge to mass ratio of an electron. In case of charge, both are having the same, like magnitude of charge is same, but their masses is different. Mass of proton is having more. So the options they gave is positively charged, positive rays are positively charged. The first option is positive rays are positively charged. The second one is charge on positive rays is less. Charge on positive rays is less, and positive rays comprise ions atoms whose mass is higher. Positive rays ions are having higher mass. And the last one is experimental method for determination is wrong. Experiment determination is wrong. We saw the explanation as positive rays ions are having higher mass, right? So we'll take up the next question. Similar question again they are asking here. So yes, there they just give direct question again. So it also comes to the same thing. What they asked, S1 be the specific charge. S1 is the specific charge of cathode rays, and S2 be the positive ray, that of the positive ray. Which one is true? That is what they are asking. So this is the specific charge of what? This is the specific charge of cathode rays, which means this is about the electron, this is about the charge to mass ratio of a proton. So which is higher? We have seen, right? So S1 is greater than S2. Why? Because it is because of the mass of protons is higher. So options given are S1 equal to S2. The second one is S1 is greater than S2. Third one S1 less than S2, and fourth one any of these. The correct option is S1 is greater than S2. We will take the next question. The massive particle among the following is. Right. So options given are first one alpha particle, the second one proton, third one deuteron is beta particle, right? So we know in alpha particle, proton, deuteron and beta particle, here what we have to see is alpha particle is what? Helium-224 with 2 electrons removed, which means He2 plus. That means what is the mass number of alpha particle? It is 4. So it is 4, and that of the proton is like proton means which contains a mass of, right, the mass number, right, mass number is nothing but the number of protons plus number of neutrons, we'll say. So the proton is having relatively 1, deuterium is 2, and beta particle is also 1. So the correct option will be alpha particle. It is having 4 mass number, right. So the right. So we'll go to the next question. Which of the following statements about the electron is incorrect? They are asking to find the which is the incorrect statement. First option is it is negatively charged particle. Negatively charged particle. Second one, mass of electron is equal to mass of neutron. Mass of electron equal to mass of neutron. Basic constituent of all atoms, basic constituent of all atoms. And the fourth one is it is the constituent of cathode rays. We have seen in the cathode ray tube experiment, what did you see? Yes, it is negatively charged particle. This is right. Basic constituent of all atoms, right. This also we have seen. This is also right. Constituent of cathode rays, we have seen again. Cathode rays consists of negatively charged particles with they named it as electrons. So this is also correct. So what did they ask? Which of the following statements about the electrons is incorrect? Incorrect statement is mass of an electron is never equal to mass of the electron is equal to mass of the neutron, which is a wrong statement, because mass of an electron is not at all equal to mass of a neutron. Mass of neutron is higher. Ernest Rutherford's model of the atom didn't specifically include. What is the particle that is not specifically included in the Rutherford model? That is what they are asking. The first option is proton, electron, nucleus. Fourth one, neutron. These are the 4 options. What is the question? We will read it again. Rutherford's model of an atom didn't specifically include. What is the particle that Rutherford model didn't specifically include? Yesterday we were talking about Rutherford model. So there he was telling that positively charged, whatever the positive charge is present inside the atom, that is densely concentrated in the center of the atom, which he named it as nucleus. That's all. He didn't say anything about what is present in the nucleus. But we know nucleus is present. In nucleus, what are the present? Protons and neutrons. These both are called as nucleons, right? So he didn't specifically include what is that called neutron. So the correct option will be this one. We'll go to the next one. The conclusion of Rutherford scattering experiment does not include. Which is not included in the Rutherford scattering experiment? What are the options given? Alpha particle can come with a closer within a distance of order of 10 to the power minus 14 to the nucleus. Alpha particle can come up to 10 to the power minus 14 meters distance to nucleus. And the other one is the radius of the nucleus is less than 10 to the power minus 14 meters. And the third one is scattering follows Coulomb's law. Scattering follows Coulomb's law. And the last option they gave is positively charged particles of an atom move with extremely high velocities. Positively charged particles move with high velocities. Move with high velocities. That is what they gave. In the Rutherford experiment, we have seen alpha particles can go up to 10 power minus 14 because whenever they are going up to that distance, we have seen yesterday that 10 to the power minus 15 meters is the radius of the nucleus of the atom. Almost they are going to the nearer, that means 10 to the power minus 14 meters they are going alpha particle, that is why they are having little bit of deflection. You have seen this one. Radius is less than 10 to the power minus 15 meters, right? This is the radius of the nucleus is 10 to the power minus 15 meters, so it is less than. This is also correct statement. Scattering follows Coulomb's law. Yes, it is scattering, it also follows the Coulomb's law. So, what is the last option? Positively charged particles move with higher velocity. This one they didn't include, which means Rutherford didn't include in his atomic model. So, this is the option, because what they asked, the conclusions of Rutherford scattering experiment does not include. ఏది ఇందులో ఇంక్లూడ్ అవ్వలేదు అని అడుగుతున్నారు Rutherford experiment లో. So, this is the option. We'll take up the one more question from the next exercise. The value of charge on the oil droplets. So, we have seen Millikan oil drop experiment, and from there we also saw what he gave the formula is Q equal to Ne, which is this is the charge on oil droplet. This is integral multiple or integer. N is an integer. This is the charge of electron. This should be integer. It cannot be some 1.01, 1.1, nothing like that, right? Right. So, the value of charge on the oil droplets experimentally observed were, what they observed is in two oil droplets, what they observed is 1.6 into 10 to the power of minus 19 and minus 4 into 10 to the power of minus 9 coulomb. This is what they observed on the two oil droplets. So, they are giving the Q values. This is Q1 and Q2. And what they are asking, the value of electronic charge indicated by these results is, what is the charge of this one, electronic charge, or the charge of an electron from this, so that it obeys this formula, right? So, Q1 is equal to some N1 into E and Q2 is equal to some N2 into E, and N1 and N2 should be a integers. So, we will see what are the options given first. The first one is 1.6 into 10 to the power minus 19, second one is minus 2.4 into 10 to the power of minus 19, third one is minus 4 into 10 to the power minus 19, fourth one is minus 0.8 into 10 to the power minus 19. From this we can know that Q1 by N1 is equal to E and Q2 by N2 is E, or otherwise Q1 by E is N1 and Q2 by E is N2, that we should get. So, we will take options and we will substitute and we will see. So, if I take Q1 by E from the given option, minus 1.6 into 10 to the power minus 19 coulombs by 1.6 into 10 to the power minus 19, it gives 1, right? Alright. Then if I divide with Q2, then what happens? What is Q2? Q2 is minus 4 into 10 to the power of minus 19 coulombs by 1.6 into 10 to the power of minus 19 coulomb. This one get cancelled. 4 by 1.6 or 40 by 16. It doesn't give you a single digit number. It is something like 2 point something you are getting. Then this is not a option. This is not the correct option. Then we will go to the second one. That is, if you take 1.6 into 10 to the power of minus 19 coulombs by minus 2.4 into 10 to the power of minus 19, again it is 16 by 24, minus 24 is nothing but 2 by 3, it's not, it is also not an integer. So, the second option is also wrong. So, if you take the third one, 1.6 into 10 to the power of minus 19, this is Q1 by E. If I take minus 4 into 10 to the power of minus 19, I am getting what? 0.4, which is not a integer. So, this is also wrong. If I take the fourth option, let us see 1.6 into 10 to the power of minus 19 coulombs by minus 1.8 into 10 to the power of minus 19 coulombs. So, it gives me 2, it is an integer, right, with the it is like, sorry, this is n1, it is an integer, it obeys the given formula. At the same time, if I take minus 4 into 10 to the power of minus 19 coulombs divided by minus 0.8, is it minus 0.8? Right, minus 0.8 into 10 to the power of minus 19 coulombs, then I will get 5, it is an integer. Both are satisfying the integer condition, like n should be an particularly integer. So, the correct option will be the fourth one. Alright, we will take one more question from the charge to mass ratio. Charge to mass ratio, we will take one more question. Charge to mass ratio of alpha particle is approximately to that of the charge to mass ratio of proton. They are asking the charge to mass ratio of alpha particle to that of charge to mass ratio of proton. Alright. So, what we have to do now? Charge to mass ratio of what? It is having alpha particle is what? He2 plus. So, it is having a charge of 2 by mass is 4 protons, it is having of alpha particle divided by what is the charge? Relatively it is 1 by 1 of proton, which is 2 by 4 into 1 by 1, which is nothing but we will get 1 by 2. That is charge to mass ratio of an alpha particle to the charge to mass ratio of proton, that is to 1 is equal to 1:2, which means the charge to mass ratio of alpha particle is approximately twice. If I multiply with 2 that of the charge to mass ratio of proton, I will get the charge to mass ratio of an alpha particle. So, the correct option will be the correct option is twice. The correct option is 2. Yes, the increasing order of specific charge of electron, proton, neutron and alpha particle. They are asking the increasing order of specific charge. Specific charge in the sense charge to mass ratio they are asking. In all this, it is having charge, it is not having charge, it is also having charge. So, the charge of neutron is 0. We have discussed yesterday as well. Therefore, charge to mass ratio of neutron is the smallest. N has the, which means neutron has the smallest one, and that of the, we will compare these two first, electron and proton. Charge to mass ratio of electron, charge to mass ratio of proton. Which is higher? Yes, we have discussed that this is higher. And we will take up about the alpha particle. Alpha particle is with respect to proton, which is higher? Right. With respect to proton, charge to mass ratio of proton and charge to mass ratio of alpha particle, if I take, this is higher. We discussed before this question that this one. So, what is the increasing order? Increasing order will be smallest is neutron and the next smallest is proton, next one is electron and the last one is alpha particle. This is the order we need to increasing order of the specific charge. Right. So, we will take a few more questions from here. Right. The E by M ratio of cathode ray is E by M ratio of cathode rays, which means electron is X unit. When hydrogen is filled in the discharge tube, what will be the value of deuterium is filled in the inlet? So X unit when H2 gas is filled. But what is the charge to mass ratio of an electron when deuterium gas is filled? That is what they are asking. In the cathode ray tube experiment, we saw that it is irrespective of gas. Anything, whatever the gas you fill it, you will get the same value. That means we will get the same value as X, even if you fill deuterium gas. Yes. So one more last question we will take from here. So there are few more like questions, the same kind of question that are asked, same like that of the questions which we are going to solve. So alpha particles are projected towards the following metals with the same kinetic energy. Same kinetic energy they're projecting towards some metals. Towards which metal the distance of closest approach is minimum? That is what they are asking. So we'll see the first options. Cu with atomic number 29, and next with silver with atomic number 47, next gold with atomic number 79, and with calcium atomic number 20. That is what they are given the options. So alpha particles are projected towards the following metals. That is what they are asking, right? So distance of closest approach, we can we have the formula like half mv square, which is nothing but the kinetic energy is equal to the potential energy, where that alpha particles, whatever they are coming, they are having the deflection. They are almost where the kinetic energy and potential energy are equal. So what is the potential energy here? 1 by 4 pi epsilon naught Q1 Q2 by R. So which is Ke is equal to 1 by 4 pi epsilon naught. Q1 Q2 are from what? This is Ze. This is the atomic number of target molecule, target element or target atom, and this is the charge of an electron. And since we are using the alpha particle, what is the charge, what is the atomic number of helium? 2. So 2 into E divided by R. Therefore kinetic energy is equal to 1 by 4 pi epsilon naught Z 2Z E square by R. So they are asking the distance of closest approach, which is R, distance of closest approach. So we need to find R, bring R to here, then 2Z E square by kinetic energy. Right, this is the equation we have now. Then whatever they are asking, we will see now. Towards which metal the distance of closest approach is minimum? That means R should be minimum when which of the metals, if I projected towards the towards which metal if I project the alpha particle, that is what they are asking. Ante ఏ మెటల్కి నేను ఆల్ఫా పార్టికల్ ప్రొజెక్ట్ చేస్తే ఈ ఆర్ అనేది మినిమం అవుతుంది నాకు అని అడుగుతున్నారు. సో వాట్ ఈస్ గివెన్ ఫర్ అస్? జెడ్ వాల్యూస్ దే ఆర్ గివెన్. కెన్ యూ సీ జెడ్ హియర్? రైట్. సో ఆర్ ఈస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు జెడ్ from the equation, which means if I am having higher atomic number, I am having more distance of approach, which means more distance it has to approach, which means this is the value of small number. So I'll have the lowest distance of approach, this is having the higher number, so I am having the larger distance of approach. What they asked, the distance of closest approach, which means the closest distance is for the lowest atomic number. That means this is the correct option, because the atomic numbers given are 20, 29, 47 and 79, in which 20 is the least. So this is the correct option. All right. Okay, till now whatever we discussed is from the topics covered in the previous classes. So we'll take a few more questions in the upcoming classes. ఇంకొకటి ఏంటంటే మనకు ఆల్రెడీ ఈ మెటీరియల్స్ అన్నీ కూడా వచ్చేసినాయి. సో ప్లీజ్ కమ్ అండ్ కలెక్ట్ ఫ్రమ్ అవర్ కాలేజ్. Thank you.